In this video, we will be solving an exercise problem from chapter 9, from exercise number 9.2, and this is question number 2 in exercise 9.2 in the CBSE textbook of class 9. Okay, so we are given that a chord of a circle has a length that is equal to the radius of the circle. So we have a chord here AB, and the length of this chord is equal to the radius of the circle. So we have the radius as this line, which is from the center to the circumference of the circle. Similarly, we can have another radius over here. So we have what is given to us is that the line OA, OB and AB, all these three are equal. The length of the chord is equal to the radius of the circle. So that means AB is equal to OA and OB. And we are asked to find what is the angle subtended by this chord at a point on the minor arc. So minor arc is this smaller arc here, over here, below the chord. So we will mark some point, let's call that C, okay, on the minor arc, and also at a point on the major arc of the circle. So the major arc is the bigger arc over here on this side above the chord. So we can also mark another point and call it by some letter, let's say D, which is a point on the major arc. And we are asked to find what is the angle subtended by the chord at a point on the major arc. So we need to join AC and BC and find the angle ACB, and also we need to join AD and BD and find the angle ADB. Okay, that is what we are asked to find. Okay, so let us also join AC and BC. So we have AC over here and BC over here. We have joined this, and similarly we can join AD and BD. Okay, so we have now joined. So C is a point on the minor arc and D is a point on the major arc, and we are asked to find the angle ACB, which is this angle, and also the angle ADB, which is this angle. Okay, so ACB is the angle subtended by the chord AB at a point on the minor arc. So that's angle here. And angle ADB is the angle subtended by the chord AB at a point on the major arc of the circle. So this is what we have to find. And to solve this, what is given to us is that the length of the chord AB is equal to the radius of the chord. So radius of the circle, that is. So therefore, what is given to us is AB, the chord AB is equal to the radius of the circle OA, which is also equal to the other radius of the circle, which is OB. So now if we look at the triangle OAB, the triangle in black here, all the three sides of this triangle are equal, so it's an equilateral triangle. So triangle OAB is equilateral. So therefore, in an equilateral triangle, we know that all the three angles of the triangle is equal to 60 degrees. So angle OAB, which is this angle here, will be 60 degrees. Angle OBA, which is this angle over here, is also 60 degrees. And the angle AOB is also 60 degrees. So all the three angles are 60 degrees. So we are interested only in the angle AOB, which is the angle at the center of the circle. Okay, so therefore we write therefore angle AOB is equal to 60 degrees. So angles in an equilateral triangle are equal, and the sum of all the angles in a triangle is 180 degrees. So each of the angles must be 60 degrees. So 60 plus 60 plus 60 is 180 degrees. Okay, so because of the equilateral triangle property that we have here, so we get this particular angle over here, which is at the angle at the center of the circle, which is this angle here. We get this as 60 degrees. Okay, now that we know the angle at the center of the circle, we can find the angle at a point on the circumference of the circle. And we know from the theorem that the angle at the center of the circle is twice the angle at the circumference on the circle, which lies in the same direction. Okay, so the first thing we'll find is the angle subtended by the chord at a point on the major arc, which is the angle ADB. Okay, so angle ADB should be equal to half of the angle AOB, because angle ADB is the angle subtended at a point on the circumference of the circle, and AOB is the angle subtended by the chord at the center of the circle. Okay, so based on that we can write angle ADB is equal to half of angle AOB, and that is equal to half of angle AOB, which is 60 degrees. So therefore we get angle ADB as 30 degrees. Okay, so this angle ADB over here we have obtained as 30 degrees. Okay, so the angle subtended by the chord at a point on the major arc, which is angle ADB, that is equal to 30 degrees. Now we have to look at the point on the minor arc and see what is the angle subtended by the chord at this point on the minor arc. So angle ACB. So for the angle ACB, it will be the half of the angle subtended by this chord at the center of the circle, but in this case, because it is the angle is in this direction, we have to look at the reflex angle AOB. Okay, so angle ACB should be half of the reflex angle AOB. So we can write angle ACB is equal to half of reflex angle AOB. What is the reflex angle AOB? The reflex angle AOB is this angle on this direction here. So that angle will be equal to 300 degrees, because we already have 60 degrees as the angle AOB. So the reflex angle should be 360 minus the 60, which will be 300 degrees. Okay, so this angle over here is equal to 300 degrees. So because the sum of the entire angle in the circle should be 360, and since we already have 60 here, what is remaining here will be 360 minus the 60, which should be equal to 300 degrees. So the angle subtended at the center by the chord AB in this direction is equal to 300 degrees, and correspondingly so that's basically the reflex angle AOB, and correspondingly the angle subtended by the chord AB at a point on the minor arc, which is angle ACB, it will be half of the reflex angle AOB. So the reflex angle AOB is 300 degrees, so therefore we will have it as half of 300 degrees, which is equal to 150 degrees. So this angle ACB here is going to be equal to 150 degrees. Okay, so we have basically used the property that angle at the center is double the angle at the circumference. How did we get this relationship that ADB is half of AOB and angle ACB is half of the reflex AOB? This is from the theorem, which states that the angle at the center of the circle is equal to half of the angle subtended at any other point on the circle. But we have to look at the angle in the same direction. So this 60 is in the upward direction here, so ADB is also in the upward direction. Similarly, for ACB, it's in the downward direction from the chord. So similarly, we have to look at this angle at the center from in the downward direction also. So that way we look at the reflex angle. Okay, so let me write how did we get this relationship of half of the angle at the center. That's from the theorem. So this is the theorem which gives us this relationship. Okay, the angle subtended by the chord at the center of the circle is twice the angle subtended by the chord at the circumference of the circle. Okay, so that's why we have the angle ADB as half of the angle AOB, or in other words, the angle at the center AOB is 2 times the angle at the circumference of the circle. So if this is 30, this is 60. Similarly, this is 150, therefore this is 100, 300 that is. So we have been given the angle at the center, and from that we were able to calculate the angle on the major arc as well as on the minor arc. Okay, so when we look at the question, we should not get bogged down too much worrying how to work out, because none of the values have been given to us in this question. Okay, there is no angle value given, no other information is given other than the fact that the length of the chord is equal to the radius of the chord. So the first thing you should do when you are dealing with these kind of questions is to make the diagram. So make the circle, then make the chord, and then the information given is that the length of the chord is equal to the radius of the circle. So use that information and then join the radius. Okay, basically construct the radius by joining from the center to each of the points on the chord, and that way you will get an equilateral triangle. And once you get an equilateral triangle, you can use the property of the equilateral triangle to figure out what is the angle at the center, and then you can apply the theorem that the angle at the center is twice the angle at any point on the circle, or vice versa. Conversely, you can say that the angle at any point on the circumference is half the angle at the center. And because we know what is the angle at the center, we can now calculate what is the angle at the major arc. And then by using the reflex angle property, we can also calculate what is the angle subtended by the chord on the minor arc as well. Okay.